Alright, so today we will be talking about verifying trig identities. Alright, now some things to do. Now verifying trig identities is when you're given two sides of an equation. You know what it equals, you know the left side, you know the right side, you know that they're both going to be equal, but what you're doing is verifying that the process of simplifying one side turns into the other side. Okay, and here's some steps and some little helpful hints on how to actually do it. Okay, so first one, transform the more complicated side of the identity into simpler side. Very good helpful hint. It helps out most of the time. Okay, substitute one or more basic trig identities to simplify identities. Very helpful because you're taking the basics and then applying them to what you know now. Okay, factor or multiply to simplify expressions. Okay, and I should probably type that with an X. How did I miss that? I will never know. There we go. Okay, factor or multiply to simplify expressions. So if you're getting something complicated and you notice that they both share a certain trig identity, factor it out. Multiply expressions by an expression equal to 1. In other words, you know, it's like common denominators. Multiply top and bottom by it. It's an old calculus trick that everyone uses. Okay, and then express all trig functions in terms of sine and cosine if all else fails. You know, try to get everything in terms of sine and cosine, and it just makes your job a whole lot easier. And sometimes when you're stuck, multiply top and bottom by a conjugate. Okay, and that, I know that's a part of this one right here, but it's a very specific one because some people forget about the conjugate. Okay, especially when you're dealing with binomials. Alright, so first off, we are going to simplify, or we're going to verify secant squared x minus tangent x times cotangent of x equals tangent squared x. So what you want to do is you want to deal with the more complicated side first. Now I don't know about you, but I think this is the more complicated side. Okay, so what I'm going to do is I'm going to start transferring stuff down. Now right here, I'm like looking at this, tangent x times cotangent of x, and I'm wondering if that's something. Okay, I'm going to change this into its version of, let me see, what is that? That is 1 over tangent of x. Okay, well if that's tangent of x and this is tangent of x over 1 and it's times by, and when you simplify, you know, you kind of write that out. Tangent of x over 1 times 1 over tangent x, that's just going to simplify to just a big fat 1. So now this whole left side becomes secant, secant boom, squared x minus 1 equals tangent squared x. Okay, and if you need to, go back to your trig identities, and here we go. And let's look, let's see what's going on. Okay, I know tangent squared and secant squared appear right here. Oh my goodness, look at that. That's that one right there. So I can simplify secant squared x minus 1 into tangent squared x. Okay? And so my final step is to basically say tangent squared x equals tangent squared x. Okay? It's as simple as that. So now I've verified that you can simplify secant squared x minus tangent x times cotangent of x into just tangent squared x. So in the future, if you see this, just simplify it to this. And once you verify an identity, you can always use it in the future. Okay? Alright, now this one right here. Okay, verify that sine of theta, 7 sine of theta plus 5 cosine of theta over sine of theta times cosine of theta is also equal to 7 secant theta plus 5 cosecant theta. Now I know I said before, try to work with the most complicated side, but to be honest, if you try to work with this, you're separating two fractions, and this is going to be partial fractions with this, and we don't want to do that as much. But I can change these in the terms of sine and cosine. Okay, so this becomes, all right, equals 7 over cosine of theta plus 5 over sine of theta. Okay, so that actually turns into that. Now originally it was 1 over cosine, but I times it by 7 and just worked with it. Okay, now I have it in terms of sine and cosine. All right, but I'm missing the sine and cosine next to the 7 and the 5 respectively. So I need to treat this like, oh wait, these are fractions, so I need to multiply by the common denominator. Now the common denominator is going to be, let's put the equal sign, it's going to be 7 times sine of theta divided by cosine of theta sine of theta, and then plus 5 times cosine of theta divided by sine of theta cosine of theta. Okay? Now if you notice, now I have the cosine of theta and the sine of theta both underneath like I wanted to over here, so that's a very good sign. And both of them are common denominators, so now I can add the top. Now I can't change the top any, but it does become 7 sine of theta plus 5 cosine of theta divided by, let's just change it to sine of theta cosine of theta. And look at that, it's the same exact identity, and this just came from adding two fractions together. Okay, alright, so that's verifying trig identities. So that means in the future, if you want to change this, you can actually change it into this pretty fast because we've proven this identity. Identities to trig are like what proofs are to geometry. They're logical steps that you have to follow in order using logical steps that just step up. Okay. All right. Now, finding one trig function. Find one trig function if cotangent of x divided by cosine of x is equal to 1/2. Okay. If we take a look at this and we try to simplify this a little bit, what we're going to do is we're going to simplify the cosine of x over the sine, or the cosine of x. Okay, so what I'm going to do is I'm going to separate it into two parts. Cotangent of x times 1 over cosine of x. Okay, and cotangent of x, if I look back at my remembrance stuff, is cosine of x divided by sine of x, and then it's times by 1 over cosine of x. Alright, now if you see where we're going, you're a lucky person, because guess what? When I multiply these two are going to cancel out to ones. Well, not cancel, but they're going to simplify to ones. And I'm left with 1 over sine of x equals 2. Well, that's not a trig identity. So I simplify this by its reciprocal identity, and that becomes cosecant of x equals 2. Okay? Alright, and voila, you've actually been able to figure out what is going on with it. Now, you could also say conversely, that means that sine of x is equal to 1/2. You know, so that's something interesting to think about. And then you can go from there. You can probably figure out that sine of x is probably, x is going to be equal to 30 degrees. You know, or you could do cosecant inverse of both sides and get that as well. Okay, so that's some really cool stuff to actually figure out, some interesting ways of working around a trig. As long as you're working, though, make sure you follow these rules and you just follow with it. And I strongly recommend try all of the problems in the book and just practice them. Practice going through them, practice seeing them, and try them and use your basic identities to help out. Because when you do it, it just makes your job a whole lot easier later on when you're dealing with trig in calculus. Okay, that's it for verifying trig identities. I will talk to you guys later. Bye.